Hey everybody, welcome to the Althea L1 embedded application workshop. And what we're going to do uh, over the course of this workshop is we're going to live code a very simple liquid infrastructure application. Thanks for your patience. I know we were a couple minutes late getting started. I was getting a fresh development environment set up here so that we can sort of present from the start how to get started and how to use this. But first off, um, what is liquid infrastructure? What is AltheaL1? What is Althea? And I'm going to give that introduction with JR, who will be helping me out today.
Good morning, folks.
Cool. So let's see. Um, so Althea is an application for buying and selling bandwidth between routers programmatically. So it allows you to buy or sell individual bytes of data in sort of a streaming manner. So there's micropayments on average about 30 cents that are used to settle the movement of data in the system. And what Althea L1 is a platform for is a platform for micropayments and revenue generating devices. Meaning applications like the Althea bandwidth buying and selling protocol, or something like a vending machine, fast car charging, um, live streaming of media, generally anything that can be denominated as a small transaction that requires instant finality. And this takes us to liquid infrastructure. And liquid infrastructure is sort of the answer to the question of how do you manage a bunch of revenue generating on chain devices. So let's say I have a vending machine and it sells candy bars for USDC, and this settles onto Althea L1. Um, there's the vending machine needs an address to pay, but I certainly don't want to care about the private key of the vending machine. Obviously, somebody could try and break into it. There's no need for the money to actually be held there. And ideally, I would like that wallet to be a cold wallet. But I may have many hundreds of vending machines that I'm managing, at which point doing it all one at a time would get rather tedious and extremely difficult to keep track of. And this is where liquid infrastructure comes in. Liquid infrastructure is a form of account abstraction that creates a NFT representation of a given account on the Althea L1 chain that would hold that account's revenue and give some control over it. And we're going to go into the exact details over the course of the workshop. Um, but the idea being that I can simply have a cold wallet with hundreds of NFTs representing my hundreds of vending machines without having to keep track of a ton of different seed phrases or worry about how each of them are managed individually. Um, so in this workshop, we're going to be writing a very simple liquid infrastructure application, meaning I'm going to be walking through the Rust SDK, how to create an account, move a few tokens around, and then generate the NFT representation of that account. Um, so yeah, I think that is what I have as far as intro. JR, do you have anything you think I've missed or anything else?
No, I don't think so. I think that's a great intro. I mean, I think everyone's excited to see some applications being made live. One thing that I posted in the Discord iFi hackathon channel the other day. By the way, everyone, please do join the Discord if you have any questions about the current hackathon, liquid infrastructure, anything to do with Althea L1. But yeah, I posted one the other day where a lot of my background is working in events, so and most of the assets that go to any event are rented. So whether there could be a link, some kind of rental slash asset management extension to liquid infrastructure, that would be pretty interesting. I mean, obviously, rental is a big revenue generator in a lot of different industries, but yeah, that if the folks out there, if they've got any interest in working on something like that, I can see a big market for that area. But yeah, Justin, go right ahead. We're excited to see what can be built.
Yeah, thank you. And this is sort of so we started by developing the Althea bandwidth application, and we sort of boiled down to what do we need from a layer one? We need instant finality, and we need some way to help manage all these accounts. Um, and this is how we ended up on the requirements for AltheaL1, which are actually fairly general. You know, a lot of pretty much any revenue generating application that's going to settle onto a blockchain immediately runs into these same problems that we've had with the Althea bandwidth selling protocol. So that's why we're sort of taking AltheaL1 and presenting it as a larger platform for many different types of applications to use, because we found that typically the problems that we have trying to build a real world application, buying and selling data, where people are actually using this day to day, show up pretty commonly. So I expect that there's a lot of different applications you could design for the hackathon that would make great use of these features. Now,
Just as a
mhm.
quick question, Justin, what's the sort of transaction size? Obviously there are people today receiving internet service and it's being billed via the Althea L1. What's the typical sort of transaction size that most people are doing on the platform currently?
So it's about 30 cents, and that results in maybe a transaction every 10, 15 seconds. You know, Depending on the exact structure of the network and all of that, which is pretty achievable. You don't want to go too much faster than that on an individual node, or you start seeing weird stuff with race conditions. But that's something that AltheaL1 will help improve, is to try and reduce the finality period and give a little bit more wiggle room. But that's specifically for a bandwidth selling application, and that's what makes the most sense there.
Yeah.
Um,
I mean,
so
I
obviously,
think
we're
the
not going to limit it to 30 cents. People can pick their own settlement amount.
Yeah, but it's great to see that there's a real world application out there today delivering the promise of microtransactions and micro payments that's actually delivering service right now. There's been a lot of talk over the years about delivering micropayments and microtransactions, but this is live, working, running. So it gives people some confidence that they're building on a platform that has provenance and has, proof that it is operational today.
Yeah, we took sort of an odd approach, or well, what is considered to be an odd approach in this space, at least, of first building our application, getting users. These are more than 1,000 homes using these connections as their internet right now, and then we went and asked, okay, well, how do we what does this platform need? What could help improve it? Rather than building the platform first, and then going and trying to build an application. So we're application first, and our AltheaL1 as a platform is shaped by what we need, and sort of how we are actually um, interacting with customers. Now, let's see. Without further ado, let's get to some code. So I have here a blank Fedora setup because that's my preferred version of Linux. I wanted to start with something blank to sort of show the entire setup process and show the documentation process, and to not precede this with my working development environment. So there is going to be a little bit of um, installation and setup tasks, which I'm putting in here. So first of all, um, I need to go ahead and grab a terminal. And with that, let's see, VS Code, all the normal stuff. So this is a Rust SDK, and this is sort of the sweet spot for the sort of embedded applications that we're working on. So let's see. Okay, I clearly can't narrate and do this at the same time. So just give me 5 minutes to get this set up. Now you can use any Linux distribution or even Windows with the Linux compatibility layer, or even you can probably build. No, you can definitely build Windows native Rust binaries that use this library. That works fine. I'm just not doing it myself. So your dev setup may vary, but I'll go ahead and give an example here. So next up. So yeah, I was talking about specifically why Rust as the language. It's very fast, useful. The binary size is a little large for embedded applications, but at the scale we're working on, which is sort of a home Wi-Fi router, maybe a Raspberry Pi Zero, something like that. An embedded computer with I guess the technical definition would be an embedded computer with at least a few hundred megabytes of RAM and a double-digit megabyte number of storage. So that also fits most of these OpenWRT routers. So that is the existing Althea platform. Let's see, bash RC. That's what I'm looking for.
For a connected device, we're typically using OpenWRT as the base platform, and then building on top of that currently in the Althea network. Is that a prerequisite for a connected, let's say, car charger, using that same platform?
They could use OpenWRT for a connected car charger. I suspect more of like a BeagleBone or like a Raspberry Pi would be the target for a connected car charger. But this will be, thank you, Nick. Let me go ahead and, you're right. Let me get this font size improved. Excellent.
Just dropping in the YouTube chat a link to a free CodeCamp course, Rust programming for beginners, which people like me would find helpful. Their content is pretty good, and it's by Bo Carnes, who's one of their better tutors in the team. So yeah, worth checking out.
Yeah, so it looks like it's not letting me install the package, so this will only take a few seconds. Sorry, I had a whole setup ready. I actually started this with Ubuntu, but Ubuntu was not doing graphics acceleration right in GNOME boxes here. But anyways, while we wait, I can get back to what I was trying to narrate before, which is that Rust is really great to work with, is really performant, and is about the right size. With some tricks, you can produce binaries that are around 3 or 4 megabytes, which you can fit nicely onto most of these target devices. So an OpenWRT target device like this one I have here, this is, Linksys made a throwback router a few years ago with great OpenWRT support, and we actually have, I don't know, must be hundreds of these out in the field. So this can run Althea, and it'll run the program that we're demoing today. So that's sort of the think of that as a target environment, maybe a Raspberry Pi Zero, BeagleBone, like I've been saying. And this thing over here is really sort of, I should say, the pushing it for the router target. So this has the bare minimum 16 megabytes of storage, which is a little bit hard to deal with Rust binaries, because the smallest you can get them is down to about 2 or 3 megabytes, which is the unfortunate downside of using Rust for these sorts of applications. But the upside is that you do not have to worry so much about most bugs. And the performance is really great. And by really great, I mean we have we have a demo on GitHub. Let me get you all a link to that can do sort of 500,000 blocks downloaded in 30, 40 seconds, something like that. And this will run just fine on an embedded application. Now, this gets into a bit of fun and interesting history, which is that when we first started trying to write Althea's bandwidth sales application, we originally just expected, hey, we're going to go grab an application that sends transactions on Ethereum, as we were building a demo on Ethereum at the time, and only to find that none existed. And there were actually no viable transaction generation libraries for embedded devices on in a Rust that were A, available in Rust, and B, would work on the target devices we had. So that was a bit of a bummer situation for us, and we had to go and work on building our own transaction generation library, which is what we'll be using today. We have one of those for Ethereum and one for Cosmos SDK-based blockchains. You can find them at github.com, Althea_net/clarity. And then that would be the Ethereum library. And then github.com, Althea_net-deep space. So this is deep_space. And these are two bespoke transaction generation libraries that are for embedded devices. So they will cross-compile two MIPS, big Indian MIPS, little Indian MIPS, 32-bit targets, 64-bit targets, 16-bit targets, maybe not, but I haven't seen one of those in years at this point. So yeah, this means that these are libraries specifically designed for essentially any modern microcontroller or embedded device, as long as it is not, let's say, a Cortex M0 or something so small that it's going to have memory and storage measured in sub-megabyte levels. Anything like that is not really our target, because most things like that do not, most microcontrollers at that size don't really have a internet connection and may not even have the oomph to perform signatures in a reasonable amount of time, especially with elliptic curves. So that is the sort of target device, and should give you an idea of what you're using. For, if you want to experiment with embedded devices, doing something on AltheaL1 that maybe like the vending machine use case, that's kind of interesting. You could easily do that with a Raspberry Pi Zero or a Raspberry Pi, just an off-the-shelf microcontroller. And like I said, today we're going to take our demo application, and for the sake of time, I'm not going to put it on a Raspberry Pi, but we're going to use a program called Cross that will emulate the ARM architecture and demonstrate that the program works there. And there's actually some really interesting stuff about cross-compiling here, which I will hopefully simplify for you, because Rust is a natively compiled language. There are some tricks when it comes to cross-compiling and preparing it for the environment. Preparing it to run on the machine that you are using, which I am going to deal with and help simplify for you. Okay, here. I've about got the dev machine set up properly now, and we can get back sort of on the road with what we're doing. Let's see, any questions or thoughts? I know I've been throwing a lot of information about sort of use cases, things that are going on, that sort of stuff.
I'm keeping an eye on the YouTube. There's nothing in there at the minute. I'll check the Discord and I'll let you know if there's anything coming up, Justin.
Excellent. I appreciate it. Okay.
Nick asked if he can have the bash history when you're done.
Oh yeah, I'll post that. That's easy. Okay. Here we are. I do not need a tour of GNOME. No, thank you. So let me get that font size increased for y'all. And okay, now we can get started proper again. So yeah, you pretty much just need VS Code and Rust. I really suggest that you use the the Rust Analyzer plugin in VS Code, which I'm going to once again show you how to set up. And this part right here is going to be Linux specific, but everything after this should be pretty generic. If you were setting up your environment on Windows or anything like that, just get Visual Studio Code and Rust installed, and then after that, you'll find that the environment looks very familiar. Oh yeah, that ran. Looks very familiar to what we're doing in this video, to be a little bit more specific. Stop. Now, I do suggest you use Rust Up rather than the repository, rather than your Linux distribution's repository provided Rust, just because especially that could be a little old, and the Rust ecosystem likes to break compatibility a little bit too quickly for that to work properly yet. Okay. I need to configure this show. So as you can see, I really just went to the Rust website, ran the Rust Up installer, and now I have that working. This is doing that thing DNF does every so often. There we go. That's more reasonable. And let's see. So I'm going to run you through some of the repos here. Althea. It's -net. Yeah. So this is Deep Space. And you should really be looking at the docs.io demonstration for Deep Space and Clarity. So Clarity, as you might be able to tell, is a pun on the name Parity, which was the Rust Ethereum client we were trying to use, now called Open Ethereum. As it turned out, Parity at the time did not work correctly on 32-bit targets, much less 32-bit little Indian targets, like the MIPS routers we were trying to develop for at the time. And that's what originally inspired us to start building Clarity. So right now, Clarity is fairly well used if you actually dig around the ecosystem, and it passes the entire Rust. So let's see if I can find it. Ethereum client tests. Okay, looks like VS Code just finished. Yeah. So Clarity passes this entire sort of reference test set. By the way, was an enormous pain. But so it is a fully compatible and tested Ethereum client in its own right, really. So then let's get, now, why am I talking about Ethereum? And I should talk about this a little bit here, that the AltheaL1 has two component platforms. There is the Cosmos SDK layer, in which consensus, staking, finality, etc. is handled. And then there is the embedded EVM, which is used to manage the liquid infrastructure NFTs and as a permissionless programmable environment. That means that we end up with two different transaction libraries, one for each of these ecosystems. And that's why we're going to be using both Deep Space and Clarity today as we generate a liquid infrastructure account, deploy an NFT, and then interact with that NFT a little bit. I do not really care about my theming or my editing or my side-by-side usage. Okay. Now, what we want to do next is we want to make a new project. Get init AltheaL1 workshop demo. Okay, cargo init. AltheaL1 workshop demo. I never initialized this repo. Sorry, this terminal. So in this case, if I just were to open a new tab, it would successfully have the cargo init AltheaL1 workshop. There we go. So let's head over to VS Code and open up our new project. So what I did there was that I just created a Git repository, and then I created inside of that a Rust project. And that is going to be everything we need to get started. So first of all, you do want the Rust Analyzer extension. So if you are working on Windows or something else, this is where you want to pick up and start following instructions. So Rust Analyzer, very useful. You want it, please get it. It will make VS Code much, much nicer as a development experience. And I don't recommend doing anything other than that. So then now I'm going to go ahead and add clarity equals, let me see, what was that latest version here? The latest version of clarity is 1.2, and the latest version of deep space is 2.21. 1.2 deep space equals 2.21. And now I'm just going to go ahead and warm up the compile cache by running cargo check all. So if you're not very familiar with Rust, let's see, required by package. Well, I do kind of have to spell the package name correctly, don't I? Cool. Yeah, so here we go. This is going to be your first sort of issue. We don't have GCC installed, apt-get installed. This is Fedora DNF install GCC. And this is one of the reasons why I wanted to use a blank machine as a way to make a good workshop video for people who are getting started for the first time or may not have experience in this, so that you can see similar errors and try and figure it out. So what you would want to install on a blank Ubuntu install was maybe build utils or something like that. Build essential is the name of the meta package, build-essential. So that's, let's see, I should add a package dependencies list to these repository readmes. Okay, there we go. So we now have imported the libraries. I've checked compilation here. We managed to run a nice little Hello World application. We can do cargo run and hello world. There we go. So now we have to actually start some business logic. So let's see. The proto is going to be the last thing we need for today. The proto. Here we are. So Althea Proto provides protobuf definitions to interact with Althea chain, and it's version 0.1.4. Click up here.
Just while you're doing that, Justin, I'm going to say cheerio to everyone. I have an appointment I have to run to. Slight conflict there, but there you go. I've got to have some stitches out. But yeah, Justin's up and running, and I'm sure you're going to enjoy what's coming next. And if you have any questions, as we said before, please do hop in the Althea Discord. You can find a link to join at althea.net, and feel free to email myself anytime if you have any questions. I'll connect you with the right people because I probably can't answer them. But yeah, email jeremy@althea.systems. And for today, I'll say goodbye. Thanks, Justin.
See you later, Jeremy. 1 second. Let me get the Discord channel up myself over here so I can see any questions people are dropping in Discord. So I can see YouTube and Discord pretty well and should be able to answer your questions right away. So I'm watching the... What channel am I looking at here? I'm watching the iFi 2023 channel in Discord or just general notifications. So please let me know if you have any questions. That and, of course, the YouTube chat. Nick, is this big enough? Can everybody read this okay? Please let me know. And now let's see. We've got our hello world. We've got all this set up. Now it's time to start having some fun. Now, the first thing we want to do here is actually that we're going to make our our main function async. And I'm going to share with you a little trick here that it took me a while to learn, but is actually really darn useful in my opinion. Because it lets us just turn our main function into an async function. And in Rust, well, if you're familiar with async from JavaScript or somewhere else, it's the same idea except on a compiled language. In the early days of Althea, we actually had to deal with this as we had to deal with futures before async was written in Rust, and that was a pain you do not wish to have described to you. It was very not fun. But nowadays, life is actually pretty easy in async land, and I'm happy to be able to show it off to you. And I think I'm going to have to install Vim key bindings in this thing before I go insane, because I just look like a fool when you put a text editor in front of me that doesn't use Vim key bindings. Default runtime feature, yeah. RT multi-thread. So then we want, what's the exact syntax? Wouldn't mind 2 more size bumps. Let's do that then. Big. Okay, very nice. So that's all working now. Let me go ahead and make sure that this returns a type. You see now we have the nice little, so it's Rust Analyzer that causes this. So you really want to install that extension. And that lets you just click the next button. Oh, let's see. I've picked the wrong tag. So I'm going to go read the documentation, as everybody should regularly. Path version, what do they call it? Sorry, I'm trying to find the flag that you use to specify the version. Version equals. That looks right. Oh, versions. Once again, misspelling gets me. Okay, cool. So now I think we have everything we need to really get started writing some code and all of that. And let me start with const rbc URL equals rbc URL cosmos, grpc. str equals HTTPS. This is going to be HTTP. Althea.zone 9090. So this is going to be the provided RPC. 1 second. I've got to get my Vim key bindings. Yes, there we go. Now let me go const rpc URL VM and str equals okay. So these are going to be our two different URLs for RPC servers. These are in the AltheaL1 testnet documentation. Let me go look that up for you just to show you the repo here. Yeah, AltheaL1 docs right here. So this lists this RPC and all of its various exposed APIs, of which we'll be using 2 today. EVMs, other utilities are also here, as well as guides for setting up your own nodes or anything like that if you are interested. Okay, so then what we're going to start with is, let's go ahead and start just by generating a key. So I'm going to actually come over here. Okay, so this is going to be, for the case of our demo, the wallet we're using. So let's get started. So there is no passphrase for this wallet. And then we're going to want to unwrap this error message. And now we can do key dot to address. Oh, that's not it. To address Althea. So let's go ahead and do this. There we go. As you can see, we've got a nice generated address here. And I'm actually going to go ahead and send that address some tokens on the testnet. And the testnet is what this RPC is hooked up to, so we should be able to see that in just a second. So for the sake of, well, let's go ahead and see it before we do it. So then okay. So as you can see, I just specified a type and then the dependency was automatically added up here. This is useful in a lot of ways. And once again, that's another feature provided by Rust Analyzer, so you should definitely have it. Now, timeouts in Rust are normally specified as durations, which you see got another automatic import. Let's just say that this request can time out after up to 5 seconds. And we know the chain prefix is Althea, which, I'm getting tired of typing that. Done. There we go. There we go. So now we've got a new. Now, when we initialize the contact struct, I can hop to the definitions, and okay, it only panics when there is some issue with the URL. Get balances, our address. Now, this is where that whole detour we had out there about making main async comes in. As you can see, we've got a future, and we just dot await to make that go away. And then we can unwrap to make that. So unwrapping will just panic if it encounters an error. If you're writing a production Rust program, you use matching and other destructuring to deal with that. But for now, we're just going to panic when we encounter any problems. As you can see, here's our address. We've got no tokens. So if I head over to my wallet over here, send some tokens over. And like magic, there are some tokens. There's some Althea token for us to test with. So I'm going to pause right here and ask for any questions, comments, anything I should go over in a little bit more detail before we move on to the real sort of application programming part. Because at this point, we have an application that generates or uses an address, interacts with the Althea chain, and from here, we're going to work on sending transactions and doing other sorts of interesting tasks. Well, cool. I'm going to go ahead and keep moving. Feel free to send me any questions you have, and I'll get to them. Okay, so we've got a wallet. We could send transactions. And Contact has a lot of different API access here, so we can do anything from getting vesting info, active accounts. You can get a list of every account on the chain, getting balances, blocks, delegate. So let's see. There's a lot of, submit proposals. So these would be governance proposals. Yeah, there's a lot of different API access here. What I suggest you do is head over to docs.io and go find deep space, contact here. And this will give you a documentation list of all the associated functions that are available to you. And there's a lot more you can do on top of that because the more general functions, like send transaction, will actually accept see, this is just accepting a generic binary message. And here's some example code for how to use this. Okay, let's see. The next thing we want to do actually is pull in the Althea proto. So then we want the microTX module. So the microTX module is the Cosmos SDK side of Liquid Infrastructure, and it controls things like printing the deploying the Liquid Infrastructure NFT and sending a microTX which directs funds to the Liquid Infrastructure NFT. So let's see, message, yes, microTX. Request client. Okay, so there are two things we care about right now. There's message microTX, which is going to let us send a microtransaction, and message liquefy, which will liquefy our current account. And what that means is deploy an ERC20 representation of this account in the AltheaL1 EVM. So let me go ahead and get this started. Oh, whoops. Went to definition there. Okay. So then so in this case, I am going to grab some copy paste code here that'll make our lives a little bit easier. And this is going to get pulled into the library soon and be a little bit easier to work with. So integration tests, test runner, source, utils. So what we need here is just a little example function. It's not in this folder. So we use all of these same libraries as to write our tests. So if you're ever curious about doing something, you can just dig into the Althea net repository and look at the test itself. So here we are. This is a useful one. And we're just going to go ahead and drop that into our project here. And then this timeout is just going to be and then we've got to import some structs. As you can see, auto recommendation works just fine. And then I'm just gonna make sure that this panics if it doesn't liquefy, because I don't want to bother with So let's go and find this type URL. Okay. Now I think we are ready to liquefy this account. So this is just a pretty simple way. Well, that's not simple, but this is how you send an arbitrary transaction from the proto definitions using contact. We're going to pull in some standard utility functions. You'll see there was a bunch I was showing you just a few minutes ago off of contact, and that will be what is useful from what is a little bit easier to use here. But this will just be the utility function in contact. So if we go and we do contact dot liquefy account. Oops, that's not what I want. Okay. And here we go. Let's see. Well, it appears it is unhappy. So let's just try and attach an actual fee to that. Hmm. Uh, I think I know what I'm doing wrong here. We need to pass an EVM address for the to liquefy address. But let me make sure I've got that right. Message liquefy just has sender. What is the to liquefy even? No. No, never mind. Hmm. Okay. Let's query this transaction hash to try and get an error out of it. Okay, so if we query this transaction with the CLI, oh, I didn't generate this as an Ethernet key. Okay, that's easy enough to fix. So all I did here was that I used here, let me make this a little bit bigger, is that I used the Althea CLI and queried the transaction hash. We could actually also do this with contact, but I did not feel like writing that code. So let's go back over here and use an Ethernet account. So we want to use Ethernet. Oh, I think I need to enable features Ethernet. Here we are. See, now Ethernet private key is available. So an Ethernet account is a sort of a mix between a Cosmos account and an EVM account, which uses Ethereum-style signatures. So that's why we need to use it in this case. Now we've got a new address, which means I'm going to not have any tokens to work with, actually. So our problem is going to be, yeah, you see, no tokens. This is a problem we can solve, actually, and it's one that I'm going to have a little bit of fun solving here, because you see, let's see, return. Okay, so we're going to actually use deep space to send transactions from our old account to our new account, because why not? Key Ethernet key Cosmos key. A little premature, maybe. Send coins. So the coin we want to send is, let's say, there we go. Then the destination will be our Ethernet address. And the private key is the Cosmos key that I sent tokens to a few minutes ago. And then the timeout is going to be $30, let's say. And then let's just get a fee in here. Oh, whoops. I probably, so cargo format. There we go. That makes life easier. So, okay. Wait a second. There we go. So this defines a very simple transaction from the account in the Cosmos. So this phrase has two possible key interpretations. We sent tokens to the Cosmos one. Now we need to send it to the Ethernet one. And this will do that for us. So let's just go ahead and run it now. And this will hopefully do it all in one go, where we send the tokens from one account to another and then liquefy the account. Okay, we did successfully send ourselves some tokens, so that's good. And we're still not working. So let's take a look at the error message this time. Hey, no, that worked. Nice. Well, why are we seeing an error message over here? Maybe this just hit the timeout. I did set it a little bit low up here, right? Yeah, 5 by default. Let's try to set that to 40. So, but anyways, now we can't run this command again because the account has been liquefied. And we can just go ahead and take a look at our. So here is, let me open a notepad here. Okay, so now we have successfully deployed this NFT in the Althea EVM. Now let me go and take a look at this via one of our block explorers. Let's see, EVM, Althea scan. Okay. Tragically, it looks like the Althea Scan Explorer has not reached this block yet, so that's going to take a few minutes. I wonder if these other explorers have enough EVM enablement to deal with it. And the answer is not yet. Okay, then. Somebody just asked me a question. No, does not look like it. Okay, then. So this is an NFT address, and by default, that NFT address is going to be stored in this key phrase. So if you were to plug this into MetaMask, you would be able to go and manage that NFT just using MetaMask or any other Ethereum set of tools. We can also manage it using Clarity here, which I might get into, but we're running a little short on time. So I will leave that out since you can just use MetaMask or some existing tool for it. And frankly, the Clarity documentation is a little bit better. You'll notice if you just do Clarity here. Let me just go look at the docs or show you the docs specifically. So if we head over to, that's not what I'm looking for. This is also not what I'm looking for. Yeah, here we are. So if we just go find Clarity and then go and dig into the client. Oh, wait. Yeah, this is what I was missing. So I forgot to introduce you to Web30, which does the actual signing. So for Cosmos SDK libraries, there's only one library, DeepSpace, because the prototypes are inherently connected to the network types, whereas Clarity is split, whereas the Ethereum library is split into Clarity and Web30. And then Web30 will give you all the, you can send around NFTs, get the name, the symbol, the supply. So this should be pretty straightforward to use to interact with your Liquid infrastructure NFT programmatically if you really want to. And then there would be like claiming the rewards and such, which I will try and get into a Web30 extension for y'all. So now we've only got one last thing to bother with here, which is that we're going to send a little bit of, we're going to send a micro TX transaction, which is the special type of transaction. Nick, yeah. So the identical derived wallet is used for both chains, same mnemonic, yes. So when you have, for example, let me do this for you actually. Let me demonstrate this. So we have this address, right? This is the address of this private key phrase with the Ethermint interpretation. So if I come over here and I do Althea debug ADBR, this is really a very useful command, and I suggest you get used to it. And this debug address command tells you, hey, this is the equivalent hex address for this Betch32 address, and vice versa. If you provide it with the hex address, it'll give you a Betch32 address. And on AltheaL1, these two accounts are connected. So, for example, if I were to query the ETH balance of this address via the ETH RPC, it would show the Althea balance over on the Cosmos SDK side, and vice versa. So these are the same account, and they are doing the same thing. It's just across the two different programming environments. So this is the address where you would find that NFT that we just deployed. And this is also the address you would see in MetaMask if you were to import this private key phrase, et cetera, et cetera. So yeah, now the last thing we're going to be doing today is sending a micro-TX, and it is only microtransactions, not standard transactions, that are integrated with Liquid infrastructure, meaning you send a microtransaction transaction, it moves funds between accounts, and if the Liquid infrastructure is configured, actually, let me start that back again and make sure that I'm giving the whole explanation. Okay, so when you liquefy an account, the private key no longer matters all that much. Obviously, you still need it to send transactions, but what really manages the account is the Liquid infrastructure NFT. So what that Liquid infrastructure NFT is going to do is that it will allow you to configure the maximum balance of the liquefied account, and to claim income. So what will happen is that, let's say I were to send $5 to a liquefied account, and this account is configured with a working capital balance limit of $20. So the owner of the NFT says, hey, no more than $20 in this account. So I send $5 to the account, and it doesn't have any balance. That $5 stays in the account and is still under the address here. But if I keep doing that, when the balance goes to exceed $20, that money will be locked up in the Liquid infrastructure NFT and available for the holder of the NFT to claim. And what this means is that you can have a small amount of working capital in a Liquid infrastructure wallet. It can make some payments, but in general, the funds are stored in the NFT, and the NFT holder gets to decide all of this, up to and including setting the working balance of the account down to zero. At which point all transactions going into the account would immediately be locked up into the NFT. Now, this only counts for, this feature is focused on the microtransaction type. So this would be here. Let me. So the microtransaction type is a specific type of transaction that gets priority on the AltheaL1 chain inclusion because it's very simple and it pays a fee that is a percentage. So that's what makes it micro. You don't want to send $1 million if you have to pay a 5% fee on that $1 million. It would make sense to use the normal message transfer, which is what we're calling when we do send coins. This is, if we go to the definition here, you'll see under the hood, we're using message send, which is distinct from message microtransaction because it does not get priority. And the fee is denominated in terms of a flat fee, like a normal ETH transaction or something like that, rather than a percentage fee that you see in the microtransaction. And it's because of this percentage fee that the chain can prevent spam and be able to support transactions that are below what would be normally the fee minimum. For example, on Ethereum, they couldn't give certain types of transactions a discount because it would result in spam. going crazy. But by denominating the fees as a percentage, that becomes workable. So getting back to our coding exercise here, let's send a microtransaction. So I'm just going to go ahead and copy and paste this because why not? Here we are, message microtx. Now I can just have Rust Analyzer fill the fields for me. For the sake of not having to think too much about this, I'm just going to copy over. This is the amount. And then let me generate another address to use as our receiver here. Now, okay, and finally. Okay, so I've kind of hacked my way through this, through creating this quick little utility function here, which should be pulled into deep space pretty soon. And then we can go down here and say our address. Okay, simple fee, simple small amount to transfer, message sending, message, here we are. That would have caused us trouble. Cool. Okay, we should be ready to go. Not quite. We need to set up a receiver address. And this needs to be a reference, and we wait. Cool. And then we print our balance again after the second time, after that runs, so that we can see what happened. Okay, moment of truth. I did not get my type URL correct. Let me go and check the type URL. Here we are. I see. There's what we're looking for. Here we are. Message, micro. No capitalization. Fixed. And this will all be in a library soon enough so that you can just call some simple utility functions. Well, we certainly sent something because our balance is no longer an even 15 million units of Althea way. Oh, whoops. That's not what I wanted. That's what I wanted. Query TX. And auth micro TX. Cool. Well, this is a test net, and the micro TX function is designed to be used with stablecoins, not the base token. I was trying to use it with the base token just to see if we could simplify things, and I wouldn't have to go and get any of the simulated USDC units. But it looks like we need them. Ouch. Oh well. But if I had some test USDC in my account, this would work as expected. So yeah, I think that's a rough coverage of the Liquid infrastructure tooling and how you would use it. Obviously, this is all still in testnet, so it's a bit of a prototype. So sorry for any rough edges. But hopefully this makes for a good introduction to the Deep Space Library. We didn't really get to clarity today, and maybe I can follow that up next week, along with hopefully showing off the more simplified version of this with some cleaner utility functions for liquefying and sending microtransactions. So yeah, I think that about wraps up the presentation for today. I am more than happy to answer questions in Discord all the time. And we're working on this tooling a lot. So keep an eye on the AltheaL1 repo, the Deep Space repo, and the Clarity repo as we continue to improve the interface and add new features to Liquid infrastructure. Before I head out, any final questions? Cool. Thank you too, everybody. Talk to you all soon. And I'm looking forward to seeing what everybody submits for their hackathon projects.